Hello, I would like to start with my very personal experience about finding motivation for this presentation. It was back in January, and I needed to start to prepare for this presentation, but I just can't find any motivation to start to do it. And then at that time, I have a dream during night that I'm standing here at this very stage. It's 5 minutes to showdown, and I still have no presentation. And I'm trying to do it very fast, very quickly. But of course, you can't do it in 5 minutes. And then in panic, I rushed to Ilse and I said, Ilse, sorry, I can't. And then ran away. Of course, then I wake up in cold sweat. It was just a dream, but what a kickstart for motivation for presentation. So when you need to step out of your comfort zones, and probably you need to find your fear and use it as a fuel. Okay, I'm Janis Vitums. I'm part of eazyBI for more than 10 years. I was mostly doing development for eazyBI, but in recent time, I started to do more technical support. eazyBI is a company of impressive scale. It has more than 30 offices. I have a little suspicion that each is managed by just one person, however, but and no, at least all I have visited these. So, all right, let's take a little detour to very remote eazyBI office I'm working from. It's located right in the heart of the forest in the very serene Latvian countryside. Latvian countryside still remains so sparsely populated that it utilizes very antiquated addressing system featuring unique house name instead of any numbers in your address. It's a real delight to work every day from the forest, but it's real nightmare when you need to buy something online, because when you try to enter your address actually in a lot of shops, then they are screaming, "No numbers in your address." So this email from Amazon seller is really common thing in my world. So they are quite convinced that the place without address actually don't exist. This year alone, I received 3 such emails that they are not delivering anything to me. Okay. While working in technical support, my main goal is to help users. I discovered that only selected few of you have received this exclusive feature. I think it's most aesthetic thing we created, alerting you about something. So I just thought it's not fair that only a few people are seeing this beauty. So as your dedicated support guide, I think that I will help you to learn how to get these things when using eazyBI. You might notice that this maybe is not what it's promised in our program guide, but I already said my sorry to Ilse. Okay, on more serious note, what we will do, we will try to create efficient reports during these talks. We will use these reports to better understand how eazyBI consumes resources. Next, we will examine why these reports are inefficient, slow, and prone to failure. We won't be searching for most elegant report building solutions or best MDX formulas. Instead, we will identify the limiting factors that cause reports to slow down. We will come to understand that not everything is possible. As this may be brief exploration into how eazyBI functions and its limitation, on the other hand, I hope that outcome will be adjustment in the thinking patterns, how you think to build better reports. As first attempt, I experimented with creating a simple yet very large report. During this talk, I will be using eazyBI for Jira. For the data, I added around 30,000 issues into Jira. I started with maximized row count, beginning with basic measures. I quickly realized that a single dimension wouldn't be sufficient for this test, so I expanded to 3 dimensions. I was using more than 50 projects, 30 issue types, and 1,000 epics to get a report with impressive 2 million rows. Numbers are a bit random. I generated all the data in Jira. But here is the problem. It worked flawlessly. No hiccups, no timeouts, technical success, but no nice message I expected. Next attempt, hypothesis using non-empty should slow down the process due to potential inclusion of empty rows into the report. Surprisingly, report seemingly generated even quicker than before. Let's check what the eazyBI log says for that. The initial method with non-empty, 164 seconds. Without non-empty, just 65 seconds. I start to question whether my expectations for non-empty are correct. Are there more rows? Let's see what browser network log says. Browser inspection confirms that 1,000-fold more data was transmitted in the second attempt. For the first request, competition times both in browser and server are almost close, indicating few seconds overhead. However, in the second request paints different pictures. There is a 10-second gap. This discrepancy reflects the time consumed in rendering response data and transmitting it over network. Here is our first insight into slow report creation. A report with 100 megabytes is trivial for high-speed networks or for local networks like in my laptop, but it may be crippling for slower connections scenario with sluggish mobile network. Full data payload might never successfully reach you, making you see a non-finishing report. But what actually happened, why second report was faster? To answer this, we should look how eazyBI works. At the beginning, user initiates request for the report in her browser. Request travels to server. In our case, it's Jira server. It's reached eazyBI mine application process. Similarly, in the cloud, there is a mine process server. eazyBI mine process do everything eazyBI does except just one thing. It doesn't create the reports. The report creation is delegated to eazyBI child process. And child process do just one thing. It only creates report. Child process is launched on one or many Jira data center nodes. On eazyBI cloud, child process run on the separate servers. For report generation, child process uses an open source online analytical processing engine, Mondrian. It's named after Dutch painter Piet Mondrian. But sometimes I imagine that there's some small creature named Mondrian inside and crafting all the reports for us. The Mondrian engine is using database to get data for the reports and send it all the way back to the browser. As your dedicated support, I already understand that all heavy lifting occurs inside child process. It will be interesting to understand what happened there during our previous reports. The database might also be of interest as all data is located there. When purchasing computer, we focus on three main parameters: CPU, memory, and data storage disk. To get a rough idea of server workload, we also can examine these three main resources, how these three main resources were utilized. Let's examine the database. It represents storage. Red vertical line separates first report execution from the second. The first diagram shows the number of times the database was accessed. We can observe that higher database access occurred only at the beginning of report creation. The bottom diagram, we see amount of data retrieved from the database. It's noticeable that the larger report required less data from the database. The next diagram shows CPU usage. It illustrates how hard our friend Mondrian is working to generate our reports. There are no significant insights here. Both looked almost the same. The most interesting thing is the third picture, memory. The yellow part represents how much memory eazyBI child process requested from operating system, while the blue part indicates how much was actually used. We can see a significant difference here. The second report consumed considerably more memories than the first. That illustrates how eazyBI reporting engine utilizes resources. For the first report, it reads a lot of data at the beginnings and gradually generates report. For the second report, significantly fewer data reads occur, which can be attributed to data caching. eazyBI caches data for a certain amount of time. However, we can observe that generating large report structure with empty rows requires a significant amount of memory. Why wasn't the second report slower? It's because Mondrian uses cached data much more efficiently than non-cached, and it actually caches not only data from database, but already results. Okay, the next attempt was to create non-finishing report with many columns. I moved the issue dimension from the rows to columns using same epics as previously. Now it should generate 1000 epic columns multiplied by 3 basic measures. It took some time to get something, and then, boom, browser error. The web page stopped responding. What happened? There is a huge number of different objects the browser needs to display. Even on very powerful workstation like mine, in this case, there are too many objects for the browser to render. Why there were no problems with a lot of rows, but issues arose when there are many columns? We anticipate that authors sometimes create reports with large number of rows without considering what to expect from these reports. We are showing only a very small portion of these rows on browser and seamlessly adding more rows when you are scrolling down the report. But the case with too many columns is somehow very exotic to implement protection like that. Let's make one more attempt to cause the report to fail. This time I will use subtasks. Previously it was epics around 1,000 members. Subtasks are significantly more members, around 20,000. And finally timeout occurred. You may notice that timeout is 180 seconds. However, eazyBI default timeout is just 60 seconds. This is because I modified eazyBI settings to get more interesting results for this presentation. Still, it's interesting what happened during filing report inside our server. So this is how you can modify settings. What resources were used for our report creation? We see the database diagrams. Through the report creation, additional data was requested. The CPU usage was similar to our previous reports. We observed much more intense process in memory. New structures were continuously created and removed. From diagrams, we can't determine exactly why the report didn't finish on time. We can only infer that substantial amount of work was undertaken likely to create the report structure. We also observed that only a small part of CPU was utilized. Why didn't we use all the CPU? My laptop has multi-core processor, but from the graph we can see that only one core was active. Mondrian is designed in such a way that one report will use one core for, or more if there is very intense calculations. Why we don't overcome this? Doing so could be very dangerous for servers. Poorly designed report could then take down entire Jira server by capturing all CPU resources. Similarly, in the cloud where child processes have their own server, one report could block execution of all its neighbor report processes. But what if we still want to know in detail what exactly was happening? We can't identify specifics without reading and understanding Mondrian engine code. In some cases, we actually needed to delve into Mondrian code to optimize how eazyBI is creating reports. It's an open source engine, so source code is accessible. We have integrated also an option to help understand more details about how exactly the report is created. In eazyBI for Jira data centers, you can enable Mondrian profiling. To obtain profiling insights, you should enable it in system settings, and before execution of report, additionally enable profiling for the report. Okay. These are the profiling results for the report, the timed out. What we can find here, at the top there is full MDX query for the reports. As I already mentioned, eazyBI uses Mondrian analytical engine. It uses MDX query language for report generation. Report execution generates one MDX query returning a table with data. After that, eazyBI may perform some manipulations with the results to present them to user. So you can say this query is the report. The MDX query is generated by eazyBI. It incorporates user-defined calculated members and all the choices user made in report builder screen. The success of the report generation depends significantly on how efficient this query is. eazyBI makes considerable efforts to create the most optimal query possible. However, our users are quite creative and sometimes create reports we never anticipated. Then profiling results help us understand what users created and how eazyBI interpreted it. The next part is query plan. It provides technical insights how Mondrian engine will generate the result. I won't go into details here. Then comes the part with actual SQL queries executed. In this section, we can see all the SQL queries that were run, why there are both MDX and SQL queries. What is the relationship between them? In most cases, all data is stored in a relational database, and the only way to retrieve it is to use SQL queries. The SQL language was created for data manipulation and retrieval, but not for analytical needs. As we can see, we can describe a quite complex report with one MDX query, which is easy to read and understand. However, it could require many SQL queries to obtain the results described by this single MDX query. Our good friend Mondrian is doing a translation job. It translates one MDX query to many SQL queries and joins all the results into one report. In our timeout case, there are many segment load entries. We can see that Mondrian decided to load the necessary data in smaller portions and created the final report in process memory. We also observed repetitive data load in database diagrams. This confirms that what we saw here was the segment load. What we have found so far is that reports may fail simply because they are expected to handle too many information. The reasons could be external, such as network bandwidth or browser limitations, or internal, where the engine requires too much time to create the report structure. If we research how long it takes to retrieve the data structures for 2 million rows from database, we will discover that it should not take more than 10 seconds. So why were our reports failing? Imagine an analytical report with 10,000 rows. It usually doesn't make sense. For analytical reports, you expect some overview. 10,000 rows will rarely give you an overview of the problem. Most likely, you will need some aggregation of data to obtain fewer pieces of information that you can perceive by yourself. The Mondrian MDX engine is optimized for analytical processing and querying. The engine is designed to quickly summarize, analyze, and explore data, enabling users to gain insights through multidimensional analysis. However, retrieving large volumes of unaggregated, detailed data without any summarization or analysis can be inefficient. Let's consider another example with less data. I created a simple report, issues created for each 400 days. The report was generated instantly. Then, with assistance from my support colleagues, I created one calculated member. After adding this member, I received this little nice message. What happened? There are no longer huge amount of data. What the crafted calculated member do? It actually iterates through all of my 30,000 issues for each cell multiple times to do something with them. I don't go in details. The member is created very specifically in a way that it will do all the necessary calculations only in process memory. It can't use SQL queries for that. The graph shows that there were data load in the very beginning on the reports and very intense calculation consuming a lot of CPU and consuming a lot of memory. At the end, you see blue area, used memory reach the limit of available memory. This is the moment we get out of memory error. Sorry. We observed that I managed to cause simple reports to fail. Does that mean eazyBI is unstable? No. All those reports used some resources to the limit. There is no miracles in reporting engine. Report creating tasks need a physical underlying resources. When I crafted very specifically reports that will use too much underlying limited resource, it just failed. The errors are internal to eazyBI and normally don't affect Jira or parallel processes on the cloud. Why do we allow users to encounter these errors? We can't prevent all of them. We can't anticipate all the possible scenarios. And we do not want to hinder any creativity from users. Let's remember which resources we ended up using too much. The browser crashed when we had too many information to show. We had to download a huge amount of information when there were too many rows. We didn't experience actual crash, but I hope you believe me that this download might never finish on slower network. The amount of data was not far from that of full low-quality movie file. We experienced the timeout during report execution. I would like to attribute this to limited availability of CPU for report building thread. As we already discussed, without limiting this thread, could halt entire server it's running on. This could stop Jira or neighbor processes on the cloud. We also saw that even seemingly small report can crash by consuming all available memory. However, it still requires quite some time to do this. It would be hard to repeat on cloud where memory is somehow unlimited. On eazyBI Cloud, you can't set huge timeouts like I did to allow consuming too much memory. Okay, can we do something? Can we help our reports? The first thing we can do is to introduce a law forbidding the creation of inefficient reports. Why? Because often they cause a lot of problems far beyond just failing report, especially in the case of Jira server. When someone creates a slow report, they often request the admins increase the timeouts for the report. However, as we have seen, longer timeouts can lead to excessive memory consumption and may use up all available database connections. Some connections are assigned to the report while it's running. I have seen timeouts up to a few hours, which is totally unreasonable. The default HTTP timeout is 5 minutes. This means the connection to your browser is dropped after 5 minutes, but eazyBI can continue to create the report for hours. Imagine 10 users starting reports on server like this. They might even don't know that the report is still running after they receive network connection error message. Those reports still consume memory and can lead to memory errors even to the other parallel good reports because there is simply no more memory left. In touch support, when I receive the message that everything is bad, nothing is working for the Jira server, the first thing I look is the timeout, and usually it's set to something huge. Big timeouts leads to unexpected errors in places where those errors shouldn't be. Next piece of advice is from Captain Obvious, is to optimize your reports. In many cases, it's possible to optimize reports. It might be challenging, but you must understand that everything has its cost. You can wait every time for the report to finish, and the cost is your work time. You can launch many slow reports and mess up colleagues' and admins' work time, or you can ask consultants for help. For large organizations, it could be beneficial to have someone who monitors eazyBI using built-in usage statistics and advices when you encounter a slow report. I have seen organizations where instead of optimizing reports, they a few times double Jira data server memory. I even can't imagine how much it costs for them. You saw how easily it is to create inefficient reports. And remember, you always can create reports that will consume more resources than you have added. But what in cases when there is actual very complex calculations, like in my second report? Move the resource consumption somewhere else. eazyBI imports all the data for reporting needs, so you can do heavily calculations during import. No one cares if import runs 1 hour or even more during night, doing really heavy calculations, but it may solve report speed problems during day. Another thing, create multiple specialized smaller accounts. A lot of data will be duplicated, consuming huge disk space in your database, but disks are super cheap. And those smaller accounts would be able to run same reports much faster just because data cube is smaller. And finally, don't just ignore slow reports. As you can see, it may lead to a lot of other problems and hidden costs. Find your fear, like I did, for slow reports. What about eazyBI Cloud? We are limiting your options for eazyBI configuration change. From user perspective, resources appear unlimited in eazyBI Cloud. For example, when the workload in the eazyBI increases, we are launching up additional child process servers to do all the workload. And when the workload decreases, we are stopping these servers. But still, these servers consumes electricity, so you might consider that faster reports help the eazyBI to run greener and help a lot of effort for this little guy in corner. Okay, thank you for listening, and please remember that no one will love you more than eazyBI support does.